Welcome to madCAM for Jewelry. In this video, we'll discuss some general milling principles as well as some madCAM specific issues and how to avoid them in following these principles. One of the most common questions I hear from new milling users is, how do you decide where to cut and in what sequence and order? And my effort in this video is to provide you with a general approach to milling and show you how to do this in madCAM. So the principle is fairly straightforward. You cut from an area with the least amount of support, moving gradually towards an area with the most amount of support. What that means is you start at the end furthest away from your chuck or holder or support and move towards it so that one of your last operations is either finishing the support or cutting it off entirely. So let's look at the case of this medallion. We have double-sided medallion as well as a little engraving here on the top. We have a support attached to the bottom. So according to our principles, we will prep our wax stock, so trim off the excess, then work on this top part before proceeding to the sides, and then finally the support itself. So let's begin. We will, as before, create a general curve that will be used to just trim any potential issues with excess wax stock. Make sure to select your model as before, choose your tool bit, confirm that it looks correct in your simulator, and then in your 5-axis options make sure that your direction is set to from active C-plane. Whatever you see in the top window is whatever you're going to be cutting. So this is the correct positioning for our top-down cut. We'll choose along curves and make that initial line cut. We will use that mirroring script that I've mentioned before, and then we'll discuss in greater details in the next video. And we will mirror this toolpath across the axis. Now we have our stock trimming. For the purposes of brevity, I will not repeat this procedure on the other perspective. We'll just assume that this is done or your wax is thin enough to be able to handle it without. Now that our wax stock is trimmed, we can proceed to milling the top part. We'll do this by changing our C-point perspective, and all of those commands can be found here. So go to the top-down view, and we should be able to see our engraving there. There it is. And we will create a bounding curve in the form of a rectangle around this inscription. Here we will use a tool called toolpath from boundary curves, specifying a step over of your choice, let's say 0.04, and a link method of y. The reason for y is because this particular engraving is more vertically oriented rather than horizontally, so it will probably look a little bit cleaner if I do it this way. So here we are, there's our toolpath for the top part, and we can preview both the wax trimming toolpath and this one in our simulator. So there's our initial cut, and there's our top cut. So that's good. Now we can proceed to cutting out the sides. So here and here. So we change our C-plane perspective again. Make sure we're in the correct view. And once again, we need to create a boundary curve. So the way I usually do this is by creating a silhouette. You can ignore the invalid geometry warnings for now. And using a curve boolean command with delete all, clicking outside of the create silhouette. Now, depending on the bit that you're using, you may need to change this curve a little bit. I'm using a tapered 5-degree bit, which means that there's a angle on each side of the bit of 5 degrees for a total of 10.1 of a millimeter. So I'm in the habit of using the offset command with a distance of 0.1 and just clicking outside of the curve to go just a little bit beyond the boundary of the object itself. What that does is it assures me that it will also cut some of the side in addition to just the surface, which will be useful to us because we want to make sure that these edges are also cleaned out. So we'll go to our boundary curve milling. We set our link method to x, specify a step over size, and let madCAM calculate the toolpath. And depending on your step over size, depending on your tolerances, this may take either less or more time. Incidentally, the longer the toolpath calculation, the longer most likely your milling time because of the fineness of the step. In this case, this doesn't take too long, and we can see our blue covered surface here. As well, if you observe these lines kind of waterfalling a little bit down and just slightly below the middle of this object. If we kept the original line, which was right on the boundary of the object, they would stop right about here, and we would not have cleaned out the side. So on the first glance this looks good until we zoom out and notice that our starting triangle, this right angle thing that specifies where our bit enters, is at the bottom. So it will start here, moving sideways, and end up here, which is in violation of our milling principle of going from the area with most support to the least support. So this is because madCAM does not respect curve seams or anything of that sort. It simply goes from the lowest possible number on the axis of choice, so in this case, for example, our z-axis, to the highest number. So if this is our 0, it's always going to try to move from, calculates toolpath from here upwards. So this doesn't really work for us, so we have to create a little workaround. The way we do that is by selecting our model and using our Rhino mirror command to mirror it about the 0 point. The whole thing gets reflected here, and we can select it, this new reflected model, and you can show your box region here to make sure that it's the correctly selected one. And now we see that our reflection is selected, and we can repeat our toolpath calculation. Same settings as before. Now you will see that our toolpath is calculated correctly with our starting point closest to the top. So to get our toolpath back to the correct position, we'll use our mirroring script and reflect it back above 0 while deleting the original toolpath. So we can delete our previous attempts and navigate back to our original model, and you can see that it's overlaid as we expected. We can reselect our original model and run the preview, watching that to confirm that it did what we expected to do, and you will see that yes, indeed, it begins at the farthest most side and continues onwards towards our support. We can perform the same operation for the back, and this will be done the same way, basically selecting the reflected model, then choosing our C-plane, the opposite C-plane now, so you can see that our test is sort of written backwards here, repeating the same step over variables. Now our operation for this other side has been finished. Let's mirror it back. Oops. Make sure I select the correct thing here. Delete the original toolpath. And now we have our both the front and the back sides of this medallion um, correctly calculated and toolpathed. Now all that remains is to do this last segment of the support itself. So while we have our selection on our object, this reflected object, we can create a silhouette of this. We can trim it down a little bit because we might not even need this entire object, and create a curve from all of these curves put together. So here's what I was looking for. There. So as before, we offset the curve by a little bit, by about 0.10 millimeter if you're using 0.5 millimeter curve tool bit, and we perform our calculation. Because our support is symmetric, there are no differences between top and bottom. We can just do one side and use it for both. So let's reflect it back on our original model. We can now scrap this entire thing since we're done with it, and let us mirror it one more time, but this time around the z-axis. So this is our last operation. Let's re-enable all of these and watch the simulation. We do our initial cut. We do the top engraving. We do one side, moving from the furthest point to the closest point. We do the next side, going from the furthest point to the closest point. And then we cut out the support once again, moving in the furthest to closest direction. At this stage, your model is done according to the principle of that I've discussed, and it's, even though the model itself is larger than the support, it will hang on just fine by this little thing. You could add an extra operation, simple line to cut this across, or you could do this by hand. That's entirely up to you. That's all for this lesson. Thanks for watching.